A shapeshifter was given 2 regular n-sided polygons. She took some sides away from one and gave them to the other, forming 2 new regular polygons. In one of the new polygons, each interior angle is 5 times as great as the corresponding exterior angle, and in the other new polygon, each was 8 times as great. How many sides were transferred from one polygon to the other? Is it 3, 4? Who's that? Ankan?
A3.
A3? That's correct. Yeah. So Ankan has nice going. Very good. So as you might be able to tell, I'm a little astonished that you could get it that fast, but because I would still be trying to figure out how to draw the things, or maybe try to look at the number of degrees in the polygon. But go ahead, Ankan, how'd you get it?
Okay, so the thing with this is that if you start like reading from the beginning, you're going to lose a lot of time. So then I went to the important part, which is that once you transfer the sides, in the first one, the interior angle is 5 times as big as the exterior angle. So that would mean the exterior angle is 30 and the interior angle is 150. Right. So to find the number of 5 with that, you would do 360 over 30, which is 12. And then for the other one, you would get the exterior angle is 20. So then that would have 18 sides. So then you have 12 and 18, and then so they must have both started from 15 then, and then so you would transfer 3 sides from one to the other.
That's right. Right. So you would have condensed the text a little bit for what we had here. All right. Okay. So we just wanted to make sure everyone understood. Kelly thinks that's a good idea too. So very good, Ankan, getting that right so quickly. So the point totals here are 1,000 times Fibonacci numbers in pairs. So 1 and 2 are the first 1,000 times 1, and then 3 and 4 will be 1,000 times 2, and then the final point total is 5,000. All right. Here comes the 4th question. Although it may not earn you many points on Dancing with the Stars, Karthik.
B not theory.
B not theory. Right. All right. It almost sounds like a logical imperative sentence, B not theory. But Karthik, I guess I didn't say about Reidemeister moves. Did you see Reidemeister real quickly?
So I've done some research on knot theory, and so like I've done a math research project on it, and I used the Reidemeister moves in it. So that's how I do it.
So did you throw out the part about Dancing with the Stars too? Kind of like Ankan was talking with the irrelevant part. All right. So and I think so. Very good getting that so quickly. And how was the research on knot theory?
It was good. So I related it to juggling. So it's a pretty interesting project. Yeah.
And when did you do that at like a summer?
No, actually I did it at my school. So it was
very good.
Yeah.
And your school is Mass. What is your school?
It's the Mass Academy of Math and Science. So it's a STEM school, yes, in Worcester, Massachusetts.
Right. All right. So now we have more in Reidemeister, even though this might be old hat to Karthik.
Hi, I'm Colin from Williams College. And I want to tell you about knot theory. So in knot theory, what you do is you take a string or a toy, something like this, you put a knot in it, and then you glue the 2 loose ends together in order to trap the knot on the string. And we consider this particular knot the same knot, even if we move it around and rearrange it in space, so long as we don't pass it through itself. And we still consider that the same knot. Now the fundamental question in knot theory is the question, given a particular knot, given another knot, so now we have these 2 knots, how do we tell if they're the same? And the only way we currently have to do that is to try to rearrange the one and try to make it look like the other. But that's a very difficult thing to do. So Kurt Reidemeister, who was a German mathematician in the 1930s, was very interested in this question. And he decided to think about it in terms of the pictures of a knot, or what we call the projections. And what he said was there are these 3 moves that you can do that you see on the board behind me right here. 3 moves that you can do to a diagram that will preserve the knot that you have. And so none of those will change the particular knot that you have. Now the amazing part is, in fact, that goes the other way as well. Namely, if you have 2 different pictures of the same knot, there has to be a sequence of Reidemeister moves that will take you from one over to the other. And this has turned out to be an incredibly important idea in knot theory and has proved to have all kinds of very useful applications.
All right, so that was Colin Adams of Williams College. We appreciate him talking to us about knot theory, and Karthik talking to us about knot theory as well. And so you know Reidemeister moves.
Yes.
All right, good. And so now we'll see what the score is at the halfway point. So Ankan has 4,000 points, Karthik has 2,000 points, and Kelly doesn't have any points yet.